Hi everyone, welcome to a workshop by the Foothill College ISRI. Today we're going to be showing you a very simple example of a type of regression called linear regression. And if you've taken a stats class at Foothill, you probably already know what that is. So in the past workshop, we mentioned that we would be using an interface called Jupyter Notebook to do the machine learning. But we've actually decided that it's best if we use something called Colab, which is a cousin of Jupyter Notebook that was developed by Google. So the first step that you want to do is head to colab.research.google.com. And then you would probably click that you want to have a new notebook. But since I've already created a notebook for this demonstration, I'm just going to open this notebook that I've already made. Okay, so how Colab works is that it's a notebook-like environment where you can evaluate code, import different packages and libraries and use them, and overall it's very user-friendly. So I'm going to be walking through a very simple example of using linear regression to predict house prices in Boston. So the first thing that I do with this line of code here is to make the Boston dataset available in my workspace. So the Boston dataset is actually a toy dataset just for kind of playing around that's available in the sklearn or scikit-learn package. The next thing I do is I import a package called pandas, which is used for data manipulation. And then this line here just loads the Boston dataset from scikit-learn. The next line here converts that dataset into a form that's useful for us, which is a data frame object. And if you're interested in learning more about the difference between different data structures in Python, that's definitely something that you should check out, and we'll have some more links in the description where you can learn more about that. And lastly, this final command here will just visualize the first few rows of that dataset. So if I want to run this cell here, it's already actually been run because you can see the output right here. But if I was running it for the first time, I would press Shift and Enter at the same time. Or you can, of course, press that play button right there. So here I can see the first few rows of the dataset, which are visualized by the head command. So all of these variables here are the input variables. So those are the variables that I'm going to be using to predict the house price in Boston. And then this variable here, y, represents the actual house prices in Boston. So it's just an array of numbers. So each one of these numbers would correspond to one row in this data frame. Okay. So the next thing I'm going to do is import a function called train test split from the scikit-learn package. So what that function allows us to do is to take our data set of input values and outputs and split them. So I'll have part of the data set used for training, which is represented by the X train and Y train, and part of the data set used for testing, which is X test and Y test. And by setting test size equals 0.25 here, I make it so that 25% of the houses in the dataset are going to be put into the test set, with the remaining 75% in the training set. So I'm going to run this command. And next, I import the linear model from scikit-learn, which lets me do the linear regression. And I create an instance of that linear regression. So my new object is called model. Okay, so now I'm going to actually use that training data that I split from here and use it to train the model. So when I run this command, the model object is now trained based on that data. So what that means, if you take in stats, you'll know that it means we found the optimal intercept and coefficients for the line that minimizes the sum of least squares of the residuals. Okay, so the next thing I'm going to do is visualize how the model trained. So by entering model.coef_, I can see the different coefficients. So each one of these coefficients is in front of one of these variables up here. And then lastly, I can see the intercept, which is the base value. So what if I want to actually use this model to predict the house prices based on input values for houses that weren't in my training set? For that, I'll use the predict function. So I'll use model.predict on the testing data, which is the 25% of the houses that I reserve for testing. So if we do that, and I'm actually going to add a new line here, if we type predictions, these are actually the predicted values of the house prices for each of the houses that were in our testing set. So basically, we're able to extrapolate information out of our training set and use that information to predict on the test set. And then the final thing I'm going to do is just to evaluate the mean squared error of my predictions. So what that is, it's the difference between the predictions and my test value squared, and then I take the mean of all of those squared distances. So since this is an error, lower is better. And if I evaluate this cell, I get a mean squared error of about 29.8. So I hope that was helpful. Please check out the description for more links if you're interested in learning about how linear regression works or other functionalities that are provided in the scikit-learn package. Thanks, and see you next time.